Okay, so this is going to be a quick video for those tricky surface area problems whenever you've got a shape, but then maybe there's like a cutout as well. So let's talk surface area. So surface area, think of it as everything that you can touch. So my approach for this problem is going to be I can touch the entire cylinder. I can touch around the sides, I can touch the bottom, I can touch the top, but then I also have this space where there's another cylinder inside of it. And technically, if my hand were skinny enough, I could slide it down into that cylinder and touch the walls of the inside as well. So we're going to have to piece together everything. So I'm going to write out in words my approach, and then what we'll do is put a formula to it. So I know that I need to do the lateral area of the big cylinder, the outside cylinder. Let me see if I can spell cylinder. There we go. So I need the lateral area of the big cylinder. I also need to add to that the lateral area of the inside cylinder, since I can touch that with a skinny arm. Oh my gosh, why can't I spell? There we go. Okay, so I definitely need to add those together. Now the tricky part is going to be these bases, because check it out. I can touch all of this, but not that red part in the middle. So I need to add to this two circles, okay? So these two bases, but I have to subtract out two of the baby bases, those baby circles. Baby bases. Big bases. Okay, so I hope that that's clear. It's like I want to do this whole circle, but then I have to subtract out this baby one so that I can only leave that black shaded part behind. So anyway, so that's going to be my approach. Now I need some dimensions, so maybe let's pretend this said like 12. Let's pretend that across the red one, maybe the red has a diameter of 2. And maybe this is an additional 2 here and 2 here, okay? So what we're going to do with this is first find the lateral area of the big cylinder, which according to your formula chart should be 2 pi r h, okay? So we're going to do that for the big one, which would be 2 pi. Now we need the radius of the big one. So if that's 2, then this is 2 and this is 2, then halfway across would be 6 divided by 2, which is 3, and the height would be 12. So all of that goes for that. Okay, now plus I need the lateral area of the inside cylinder. So same formula, but different variables. So I need a 2 pi, okay, the r for that. So if all the way across this red part is 2, that would be the diameter. So the radius will be a 1 here, and the height will still be 12, because that little hole will go all the way back through the shape, okay? And then we're going to say plus, now we need to do this, so plus the 2 big bases, so that's going to be, since it's a circle, it's going to be pi r squared. And then when I plug that in, once again, the big one has a radius same as this one, so radius of 3, okay? And then the last is going to be minus 2 of the babies. So another pi r squared. Now those same radius as this baby, which was a 1. Woo! So this is my formula, folks, and the formula, it's not the same every time. Like, you have to think it through and piece it together based on the shapes that you see. But like my approach, I like to write out in words, what can I touch, what do I need to find, and then it makes it a little bit easier to sort of piece it all together. So I'm not going to finish this out because this part is just math, and you would just, of course, multiply, things together and then add and subtract them together. But I wanted you to get to see the layout. So hopefully that helps. Good luck.